NVIDIA just open sourced an AI that can literally see inside quantum computers and fix them autonomously. And on the world's first quantum physics benchmark, it's already beating GPT, Claude, and Gemini. This changes everything about quantum computing. But to understand why, you need to know the dirty secret nobody talks about. Everyone thinks quantum computing's biggest problem is building better qubits. They're wrong. The real bottleneck is the classical computers struggling to keep quantum machines alive. Current quantum processors error once every 1,000 operations. But fault-tolerant quantum computing demands 1 error in a trillion operations. That's a billion-fold improvement no hardware tweak alone can solve. And here's the part that will shock you. The way quantum computers get calibrated today is by PhD physicists manually staring at oscilloscope traces. They interpret spectroscopy plots by hand, tweak laser intensities, adjust microwave pulses, and then run the whole experiment again. For days. This process is so labor-intensive and non-scalable that it's been the single biggest hidden bottleneck preventing quantum computers from leaving the lab. On April 14th, 2026, World Quantum Day, NVIDIA dropped the solution. They call it Ising. Named after a 1920s physics model, Ising is a family of open-source AI models designed to be the operating system of quantum machines. The first pillar is Ising Calibration, a 35 billion parameter vision language model that acts as an autonomous digital physicist. It literally sees quantum measurement data, oscilloscope traces, spectroscopy plots, and infers the exact adjustments needed. Days of manual tuning compressed into hours. The second pillar is Ising Decoding, a tiny neural network, just 0.9 million parameters, that pre-decodes quantum errors in real time. Compared to pyMatching and the current industry standard, Ising Decoding is 2.5 times faster and 3 times more accurate. And here's the kicker. It even makes the old decoder run twice as fast on the leftover errors it couldn't catch. But performance is only half the story. NVIDIA made everything fully open source: model weights, training data, recipes, and benchmarks. Any lab on Earth can fine-tune Ising on their own proprietary quantum hardware data without ever sending that data to the cloud. The response was immediate. Over 24 institutions adopted Ising almost overnight, the broadest coalition ever formed around a single quantum software tool. From IonQ's trapped ion systems to Inflection's neutral atom platform to Sandia National Labs running national security applications. Harvard, Cornell, UC Santa Barbara, the University of Chicago, the UK National Physical Laboratory, the list reads like a who's who of quantum research. The quantum computing market is projected to hit over $9 billion by 2030. And this technology is the architecture diagram powering that growth. NVIDIA's vision is clear. GPUs become the indispensable classical backbone of every quantum computer on Earth. But let's be honest about the limits. Ising's decoder struggles with next-generation quantum codes that use long-range connections instead of local ones. The benchmarks carry up to caveats, and using a neural network black box for real-time error correction introduces debugging nightmares physicists aren't used to. Some skeptics argue this is NVIDIA strategically locking quantum computing into GPU dependency before standalone quantum hardware threatens their empire. But here's what the skeptics miss. Ising isn't a silver bullet, and it isn't a marketing stunt. It's the most significant software catalyst quantum computing has ever received. It ensures the classical infrastructure won't be the thing holding back the quantum revolution. The hardware will catch up, and when it does, the AI brain will already be waiting. If you want to stay ahead of the collision between AI and quantum computing, subscribe so you don't miss what's coming next. This story is just getting started.